Hello everyone, my name is Thomas Kim. Today is March 8th, 2019. This is 21st episode about C++ type functions, modern C++ programming. In this episode, we will learn how to overload output operator for std tuple, std variant, or how to visit each element of std tuple. We will learn how to implement compile time loop. The compile time loop plays an important role in advanced template metaprogramming or in the implementation of advanced type functions. This session continues from my previous episode. Please click this link. From this episode, click this button. Download source code by clicking this link. Click this button, Show in folder, double click, copy the folder path, copy, paste it to your working folder. Double click the folder, copy the folder path, copy, right click your command prompt, right click, properties, in starting field, Ctrl A, Ctrl V, click OK. Start Visual Studio Code. In Visual Studio Code, if it is not open, you can go File, Open Folder dialog box. Ctrl minus once again. Click in blank space. Click this button. 21. Compile time loop. Click this button. PCH CPP loop CPP. Ctrl V plus. In the PCH file, include talk play fun type util.h, include type function tutorial. In the PCH file, include PCH in the loop, include PCH auto stream talk play fun stream auto NL stream get console out int main stream compile time loop NL start command prompt dir cd 21 compile time loop dir cl at pch local pch cpp cl at msbc local loop cpp. You should see this message successfully. Let's try with GNU compiler. std C++17 PCH. We are compiling precompiled header. G++ std C++17 loop cpp o mexe m. You should see this message successfully. I create a function void test output operator for tuple variant. I define a type using tuple t std tuple int double std string. I define the tuple like this. Then tuple t I can initialize to 3.14. I love it. I defined. Then we can print out string like this, because this string class defines output operator, so the elements of tuple is displayed. And then also using variant t std variant int double std string, I defined a variant tb b equals 3 stream d equals b nl b. I define another value, I assign another value stream b equal b nl b equal, this is variant I defined like this, stream b nl. Now let's build and run. We have to call this function. Compile once again. Okay. So this line is displayed properly, variant t. This line t top this stream, in case of string class, this output operator is defined, overloaded for t tuple type. So the result is displayed properly like this. And in this case, variant, we assigned 3 to variant v, and the result is displayed 3. Then we modify the variant 3.14. We assigned 3.14 to v. Then we display v. Then we assign string. Then we display v. How these things work? I will copy this. I copied pasted std output operator for tuple and variant. Instead of a string, we modify std cout, then std and there. Then here std cout std and there. I copy once, twice, 3 times, and I copy this function and I call it like this. I will disable this part like this. Now I call this function. It doesn't compile. We try with Microsoft compiler. It doesn't compile. because this operator is not overloaded. So I will disable this part for the time being. I will disable. Now let's define operator here. We first need to understand the concept of compile time loop. So compile time loop is something like this. Here I define compile time loop like this. Template size t start index size t end index. Okay, then struct, I would say static loop, or we can say compile time loop. Compile time loop st. Okay, so I defined a class template or struct template like this. Static void remember compile time loop. Okay, constant character pointer msg. So this function, we will implement this function to compile time loop. Okay, like this. If context pair start index less than end index, then here stream index start index msg nl, we do some operation here to do. Put your logic in this section, and before closing this curly brace, we call this function recursively like this. This is struct. Now we modify like this. Start index. Please note that it does not work. Start index end index. We call this function msg. We are calling this function recursively, both using this is outer class, template class, like this. We cannot do this. This does not work because start index and end index, these are compile time constant. These cannot be modified. Okay, so this does not work. Instead of doing this, do like this. +1. Okay, please do like this. You cannot modify compile time construct. So this is typical way. Please try to remember this syntax. Then here, then we can call like this. We can call this function void test compile time loop. We are testing this function compile time loop st 0 5. So we iterate. Please note that start is 0 and the index is 5. So it iterates 0 1 2 3 4 5 times. 5 times. Okay, then we call this function remember compile time loop. Please remember this syntax. This is a compile time loop. I coined compile time loop. Okay, well, we can just break like this. Yeah, we can just break like this too. Now let's run this function. I will copy this function name, copied, paste. Now build. Yes. 0, 1, 2, 3, 4. 5 times iterated. Or I can give another like this, NL. And I can put more tab. So 0, 1, 2, 3, 4. This is a compile time loop. I coined the compile time loop. This message iterated 5 times. Please remember the syntax, this syntax. Okay, we will use this operation, this code over and over again in future sessions for more advanced topics. Now we will learn how to overload output operator, stream operator, like this. Template, type name, tuple type, static, void, print, tuple, std, ostream, os, constant, tuple, type, t. Please remember this syntax. If context pair start index less than end index, constant auto value equals std get start index t. Then here, before we close, copy this part, copy, paste, start index plus 1, end index. Please note that this is template function, so we need to provide template. We are calling this function again, os t, or we can just put it here. So this is recursion. Here we now print out os b if start index plus not equal end index. We can say os then otherwise, like this. Then here template, type name, types, std, ostream, operator, std, ostream, os, constant std tuple types tpl. Now in this function os, we call this function like this: copy zero size of types template print tuple os tpl os return os. Now we are defining print variant like this: template type name type name types static void print variant std ostream os constant std variant. I don't think we need variant. We can just say variant type. Variant type. var if context pair start index less than end index. We call this function again copy start index plus 1 end index template. We call this function again recursively os var recursion. Here if start index equals var index, this function returns, this is runtime construct. Start index is compile time entity, var index is runtime index. I say compile time index. Okay, so we can compare like this: compile time and runtime. This returns currently selected items index. Okay, then constant auto value equals std get. We have to provide compile time index like this var. Then we print out os b like this, else is this part. Okay, so it's a little bit more complex. Now here we define template type name type name types std ostream operator, std, ostream, os, constant, std, variant, type, types, var. Then we call this function copy zero size of types. Please note that we have to plus 1. Okay, don't forget, when we call this compile time tuple, we do not plus 1 because this returns the element count. In case of a variant, we have to provide like this. In case of std tuple, it is defined like this. Type name, that is std tuple, parameter count is 0 or more. So this is correct. In case of std variant, it is defined like this. Type name, the parameter count of std variant is 1 or more. So this is correct. Okay, so since this, we have to count the parameter count is the count of types plus 1 to compensate for this type. So it should be plus 1. Don't forget this. Then template, we call this function print variant. Then os, then var, like this. Then we have to return os. Okay, so we defined these functions. Now I will copy this part of code. I copy, cut, then I paste it here, paste it. Now I enable it. I enabled. Now we call this function. Now we are calling this function because these are overloaded like this. It should now work. Wow. See, we are calling this function, and this is std tuple. We are using standard cancel out this operator t here. 2.3.14. I love it. And std variant b, we are using standard cout. This is standard cout 3.14, and this is variant. So it works perfectly. But there is one problem. For example, I modified it w, then I would say L like this. If I modify like this, then it doesn't work. No, it doesn't work. Why? Because this is wide character string. We haven't defined wide character string. So let's define wide character string case. Let's see. This is tuple. I can overload it like this. For wide character string, then it can be double stream, then it should be L for wide character string. Then I can overload it once again, paste W L okay, we fixed. Then in this case we can say W. Okay, now it should work. Now it works. But you should know this is not perfect solution. This way is not perfect solution. Okay? For example, if I add one more, I will copy. No. I will disable this part. And add another string, std string. I would change white string. Byte string. Okay. Now this does not work. This does not work. No, it does not work. So I will disable it. And I copied it again. I restore it. I restore it. I disable it. Okay. Now it works. If you want to solve this problem, let's try with this string class. Let's compare with this. For example, this string class I implemented. Let's test with this one. Wide string. Okay, this is wide string. Then here I change std wide string. Then in this case it works. I disable this part. Now this is my own string class. It works perfectly. This string class can handle any type of string. But our current implementation cannot handle arbitrarily, cannot handle when we intermix with wide character string and non-wide character string in the same tuple. It does not work. To handle such kind of problem, we need to learn more in future sessions. So I will disable it. and enable it. I will try for the last time. Okay, it worked. In future sessions, we will learn a lot more advanced technique for type functions and template metaprogramming. Please subscribe to my YouTube channel. Thank you for watching.